Hello everyone, my name is Birjesh Kumar. I am in data science and business analytics intern at the Spark Foundation. I am going to explain the and prediction by using supervised machine learning, k-mean clustering to classify and predict the species. For this, now importing the required library, importing the NumPy as a NP, Panda as a PD, Matplotlib as a PLT, Seaborn as a SNS, and Matplotlib inline, basically used to plot the graph plot in a line. I don't have to write again and again plt.show. Now importing the data set. So basically pd.read csv and the file path, and data is provided by the Spark Foundation. Let's explore the data set. df.shape basically used to get the number of row and the number of column. Here we can see the 150 number of record and the 6 column. To visualize the first 5 record of the data set with their column name, df.head, and similarly df.tail to visualize the last row, basically last 5 record of the dataset with their name. df.info basically used to get the data type of each column and non-null value count, and also it give the memory usage by the dataset. df.describe basically used to get the descriptive statistics of the dataset, and it give the mean, standard deviation, first quartile, second quartile, and third quartile, and the maximum value of each column. Here we can see. Now I am going to plot the pair plot. Basically used to get the relation between the column, between the features, and it also tell the uh, outlier present in the data set. And from the above pair plot we can easily see here here petal length and the petal width. With the help of this we can easily classify the species. Here iris virginica is represented by the green color, iris versicolor represented by the orange color, iris setosa is represented by the blue color. And here you can see iris setosa easily can be classified with the any feature, but iris versicolor and iris virginica little bit difficult, but petal width and petal length we can easily classify it, so we able to know which feature is more important to include in the our model. Now I am going to divide the feature into dependent and independent feature, and here our our dependent feature is the species that we are going to target, that we are going to predict, and x is the independent feature, basically sepal length, sepal width, petal length, and petal width. Assign it to the x, and similarly target value dependent variable assigned to the one. Now I am using elbow method to find out the optimum number of cluster. So uh, basically it is an unsupervised learning, so we don't have idea we have to how much cluster we should have to make, and with the help of elbow method we able to get the optimum number of cluster. To do this, basically we plot the we plot the elbow, and in this basically what we do, here you can see that basically we take the number of cluster range between 1 to 12 we have taken basically, and we import the k-mean clustering algorithm from sklearn.cluster, and we instantiate the k-mean with the number of cluster I, init equal to k-min and random estate equal to 100. And we train the dataset on the independent variable, and we append the k-min dot inertia basically into WCSS list. Basically, it is the sum of a square distance between the each point and the centroid of the cluster. And here we have plot the basically we have plot the graph between number of cluster and the WCSS value. And here you can easily see that number of cluster is 1, WCSS value is very high, and as we increase the number of cluster 2, WCSS value increase very sharply. And when we increase the number of cluster 3, a value of WCS also increase sharply. But after that you can see key number of cluster increase, number of WCS value not decrease so much, and that's why we can say the optimum number of cluster is 3 from the above graph we can see. And now we importing the k-min cluster model and training the model. So basically a scale down dot cluster, we import the k-min cluster algorithm, and we instantiate the k-min cluster to the k-min with number of cluster 3, random estate 100. Now we train the k-min cluster with the dataset a k-min dot fit and independent variable x. And now we predict the model. So we can predict the model with two way, k-min dot predict and the dependent variable x. We can get this value equal to y k-min, and here we can get another method is k-min or k-min dot labels. We also get that. Now we have to do the two thing. First thing, we make a new column species dummy name, in which we map the categorical data with numerical. Iris setosa with 0, iris versicolor 1, iris virginica with 2. And now we another second thing also, we make a second column of predicted cluster k-min dot labels by the model, and we assign cluster column. And here we can visualize the data frame. Here we can see that a species dummy, basically we made the assign uh, map the each species with the number 0 1 2, and predicted column by model. Now visualize the original dataset and the k-min cluster dataset. Here you can easily see that original dataset setosa that easily can classify, but but uh, uh, but iris versicolor and iris virginica, uh, it is it's little bit difficult to classify, and our k-min model have classified it very well. And now we come to the model evaluation. Basically, there is no perfect way to evaluate clustering if you don't have the label. However, since we do have the label, so we take advantage of this to evaluate our cluster. Keep in mind, usually we don't have this luxury in the real world because we don't have the label. But we have a label, so we do. So to evaluate our model, basically we import two performance metrics, confusion matrix and classification report, and we print the confusion matrix and classification report. Here we can see that our precision of the model is 91% and the recall 89%, and the overall we can see 0.89, basically 89%. So this is a good model. Thank you.